All right. I always want to do that, like run onto a stage. How'd it go? No? All right, cool. Hello. Welcome to Redis as a message bus and here at RedisConf 2016. I'm Brian Leonard from TaskRabbit, and I'm here to talk to you about buses and Redis and how they really helped us out and some of the experience that we've had that led to some successes in our architecture. And I've got one of these. There we go. All right, TaskRabbit. Does anybody use TaskRabbit? Yeah, woo! TaskRabbit is a service, an app, a website to get stuff done, normal, everyday stuff. Any chore you have right now, you can probably get that done on TaskRabbit. My personal favorite is someone goes to IKEA, buys something for me, brings it back and puts it together, and, you know, magic desk. The cool thing, I think, is not only are we helping a bunch of people, you know, most specifically moms get a lot of help from TaskRabbit, lots of Mother's Day stuff happening, is that there's lots of people doing real work, like handyman work and like cleaning and stuff like that, that are living in the Bay Area even and paying rent, and you know, we're just making them a lot of money, some more than me, which is good because I have skills like typey, and they've got skills like electrical wiring and building real things in the real world. And so I'm really proud of what we built there. We used Redis. Who uses Redis? Not that guy? Not you? No Redis? Welcome to RedisConf. Well, one of the cool things about Redis is this logo. I always want to find the block to put in that logo. One of the cool things about Redis as it applies to what I'm talking about today is that you can store stuff, specifically a list, because we're going to be making queues. And that's pretty cool. But the main thing is that it's atomic, and atomic is awesome. And it allows you to make sure you can only take things out of that list one time. And a lot of the talks that I've seen and probably will see today, it's all about this atomic thing. Everyone's into I like the contrarianism of the situation. Everyone's into all this parallel stuff. You can have 30 Mongo something or another's, and they're on all these things, and they're eventually consistent, and Redis is like, no, one thread, people. We're going to make it happen. And that's really where the value comes out in a lot of the things you'll hear today that I think is super cool. All right, something you can build on top of Redis. This is going to be like, this whole talk is like a delicious layered cake of goodness starting with Redis. The next layer is Rescue. Anybody using Rescue? A little bit less. And it's more of a pyramid, I guess, because it's applicability to people what they're using. Anyway, Rescue is basically building a queue worker background job system. So you receive, your API maybe has a sign-up function, something like that. And you put a new row in your database, probably. We use MySQL. And you want to send that person an email, but you don't really want to do it right in the unicorn or whatever Nginx sort of thing you're running. You want to queue that up to happen in the background. And Redis and Rescue is for that. So how does that work? Ruby code. Ruby? One guy? No? Two? All right, cool. Python? All right, there it is. Something else? Yeah, woo! All right, cool. So in Ruby, basically after we commit our transaction on a rating, we have ratings in the TaskRabbit platform, you get someone to build your desk for you, and then you get to say whether, you know, he did a good job. Was he on time? Is the desk together? Were there extra pieces? I don't know. Whenever I do it, there's extra pieces, but when he does it, usually not. So anyway, you rate him 5 stars, let's say. After that SQL transaction is done, after commit, we call it in Rails land, then we're going to enqueue one of these rescue workers, and we're going to say, OK, background, calculate the new average for this guy. And we're going to write that to his profile. So it would look something like this. You know, probably not that surprising. How many ratings does he have? Divide that by his like sum of his score and write it to his profile. So he had 4.2 before, he got a new 5 rating, and now he's at 4.3. And that happens in the background. What does that look like if you're just Redis and you're looking at it from that level? The rating gets saved And then we enqueue up in a list the class name and the args. In this case, the args would be, say, the ID of the new rating that just got created. And it's going to get popped out by rescue, who's going to execute the relevant code to that and write to the new profile. All right, so that's how that works. Now, let's say that you read this article that said, you're doing it all wrong. You know what you have in your completely functional working system? It's a monolith, and that's junk. What you need are microservices, my friend. Not service-oriented architecture is what we called them a few years ago. Now they're microservices. And you need a profile app. And there's some benefits to that, certainly. We're going to allow this profile app is going to focus on all this crazy stuff that has nothing to do with your task app, your marketplace, payments and getting things done. The profile app is mostly about, I don't know, uploading a video or a picture or saying what kind of work you want to do and things like that. And the tiniest, smallest piece of this profile app is this one little corner of your profile that says 4.3. But just because it's tiny and not the main focus doesn't mean that information doesn't have to get over there. And so how can you use Redis as a way to communicate between these two things? Because the whole point of having the separate apps is they don't know anything about each other, or at least what we want to call loosely coupled. So you could certainly do what I just said using rescue and these two apps. So the rating gets saved. We're going to put it in some list queue name in Redis. And the profile app is going to have to know to pop that up and execute it and write to the profile. So it's great. So now they're not coupled. I would argue they weren't really that coupled before. But they can live in different repos. And we can use Redis as lots of words, right? Like a RPC mechanism, a bridge, either way, a way to communicate between these separate code bases and running instances. But is that good? Have you achieved your microservice nirvana situation? And the answer is probably no. You probably did not, specifically because the task app had to know that the profile app even exists. The best case would be that the task app doesn't even know the profile app exists, but it does because it said, oh, I just got a new rating saved, so I'm going to enqueue this thing up for the profile app, which I know exists, which is a fail if you're a microservices kind of thinker. So how could that look? I forgot. So you would do the same it actually looks almost exactly the same thing. No, I'm wrong. How would we want it to work, which is right here? Ideally, we would have sort of a pub-sub notion, which is clearly, in some way, we need to communicate to this profile app that a rating was just made and that we now need to recalculate. But we don't want the task app to know about it explicitly. So what the task app can do is publish very generically, hey, guess what? Sort of like yelling into an empty room, whether you know someone's there or not. Hey, guess what? If anyone cares, this rating just got made. End of story. And then the ideal case for our loosely coupling this rating app to the task app would be that it would subscribe whenever a rating is created and know to recalculate the total rating. So this code looks almost exactly like the code before, except they actually don't know each other. We've added this layer of indirection. If you're doing something wrong, the general strategy of computer science seems to be to make it even more abstracted or less clear of what you're actually doing, and then somehow you win in the end, and this is one example of that. So the turtles all the way down, right? All right, so this is the task app saying, if there's any other apps out there that care that a rating just got created, it is, and the profile app can subscribe to that. Now, how would that come in? And we add a new thing, which is what I'm talking about today, which is the bus driver. I love metaphors. When I make libraries, we make metaphors. And so this is the bus driver. We're going to have some riders. We've talked about how to make transfers and things like that. You know, you got to go all in on these metaphors. Either way, we're making a bus driver. So the rating is saved. And now instead of enqueuing something specific, we're going to generically publish that this thing just happened. And so now there's this event in a list, which we call the incoming queue. Incoming meaning it needs to be driven. If we went really hard in the metaphor, maybe he just entered the bus station or something. All right, the bus driver pops that, looks up in Redis who cares about this thing, and then queues it several times in different lists in Redis. So he would look up that the profile app cares that a rating got created, and maybe there's some other ones too. If you're a computer science guy, they would call this the bus driver demultiplexed the event, which is a fancy word for fan out, which is a fancy word for some gesture that kind of looks like that. Turned one into many. Great. So now on some other thread in the profile app's whole thing, it's going to pop the event and execute the same code it did before. And now you got this other one just hanging out there. Who might care about such a thing? Oh, maybe there's a fraud app. Maybe there's a whole set of code that is sort of monitoring the marketplace to know if something shady happened. Maybe it's looking at this review, and if it's a one-star review, we're going to do something about it. Or maybe there's text in the review, and like it's going to look for the word thief or steal or broke or something like that and do something about it. And so maybe the fraud app is also subscribed to this event and can pop and execute its own code. So why is this good? This is good from a sort of overarching high-level architectural view, because the task app doesn't care about any of this stuff. Good code comes from being focused on its mission. And the task app can know all about what it knows about and not care about the side effects. And it can just publish, and these two can subscribe to accomplish their missions, which happen to involve something from the task app. One of the cool things is this is just rescue. We're just putting in and out of these queues in a system that we were already running, and we've just sort of layered one more layer on top of that cake what didn't work out. Trans-America building of architectural goodness for you, San Francisco people. You've added one more layer onto something you already knew how it worked. We already knew how to deploy Redis. We already knew how to monitor rescue. We knew we had health checks in place to know that the queues got too long. And we've just added this one layer by adding this incoming queue and this bus driver concept. We got a lot of value out of that. Whereas some of the other systems we researched, we'd have a whole new architectural system. Something that really stuck with me from a talk I went to a long time ago, someone from Twitter, and said, where do you store this geo information about these tweets? And the answer was Cassandra. And someone said, why? And the answer isn't always because it's shardable, or it's this, or it's that, or it's single-threaded, or it's something about the cap theorem. Sometimes it's just, it worked and we knew how to deploy it already. And that's an example, this is an example of sort of leveraging our current infrastructure for that. The second is this whole loosely coupled thing. So each of those sections of code, the fraud and the task app and the profile thing, just go about their own business, and they don't have to know about their side effects. Local simplicity and local focus is about surface area. If I change this line of code, how much can I screw up in the whole rest of the system? And this technique minimizes that surface area. But it does so at a cost. This is not all rainbows and unicorns up here. It's about global complexity. You used to be able to easily read your app and know that when a rating is saved, the following 6 things happened because you queued them all up very explicitly. Now it's about generic pub and sub and the events flowing through the bus, sort of transiently and things like that. We've made this trade-off, and we believe the top 2, are worth the global complexity, but it's certainly something to keep in mind. And we've created these application subsystems. So what are some examples of why you might want to do this bus thing? And the first obvious one is what I've talked about here, which is you've got many of these application subsystems. We have a profile and a marketplace, and we have one account management system that handles password resets and authentication and things like that. We have a mobile subsystem which handles tokens and, I don't know, Apple push notification stuff and things like that. We've got all these different systems. Maybe you've done the microservices thing or the SOA thing. Maybe you haven't. But either way, you've got all these things that are minding their own business and but still have minor side effects in other spots. Even if you separated them perfectly, there's still these little side effects where they kind of need to know what's happening with each other. And so by using this bus, you've done what I've talked about, which is loosely coupled these items such that they can have smaller, more focused, confident code. And this isn't only for microservices, right? TaskRabbit at one point was the big, scary monolith thing. And then we just I read a blog article basically, and we blew it up. Now we've got 14 apps. And they all have these focus areas like we're talking about here. And was that good? Certainly had its pros and cons. One of the pros was the teams working on that did get all that local simplicity, local focus. They worked just on those things, and we got a ton of value from that. But the global complexity, in that case, took us down, right? It was harder to roll things out. Any given feature request is like 10 different pull requests, right? Any given feature could have been in 10 different pull requests. You had to coordinate the deploy between all of those things. And the testing was a mess because you have all these explicit, they feel loosely coupled, but they were all super related and they were all talking to each other. And we found that the real value, the best compromise for us, was realizing the real value didn't come from literally being different apps. It came from the focus and the simplicity in each file, which at the end of the day isn't microservices anything. It was more about namespacing, and they could all even be in the same app. So we sort of big banged them out, and then we brought them all back together, but in their own folders. So we got all the value, personally got all the value from microservices just by having different folders in our code bases. And the cool thing is that the approach is still the same. We still use this bus to talk between all of those things. Another kind of app we have is communications app. So you've got all this separate code bases, but there's these horizontal layers that exist between them. So just think about emails or something like that. The account subsystem needs to send an email when someone signs up maybe, or certainly needs to send one when they do a forgot password or something like that. The rating system or the task system needs to send an invoice when someone gets billed for a task. And 14 other systems, each of which need to send pushes and emails and SMSs and the like. So the architectural solution here, or architectural problem at least, is how do we not have 14 different places that have our Twilio thing, and how you talk to Twilio. And so clearly you could share code between all of those in the same code base. One other solution is to use this bus mechanism. And so everyone's publishing everything that happens, and sometimes those messages also say, oh, and by the way, I'd prefer if this person received an email with this content or received a push notification with this content. We have an app that's subscribing to this bus that looks for those events and sends the message. This is super cool because it's centralized. Only one person has to know how to talk to Twilio. There's no shared knowledge of all that. And basically what you've made here is an asynchronous API to be able to send these messages. And you can really optimize the code that does so. For example, maybe Ruby is good for most things, but talking to these external services isn't best done in Ruby for a variety of threading reasons, and doing something like that in Node would be a good idea. And you can do that via the bus. Similar case for that same reason is via these external vendors. There's all these, it's like you make this whole new shiny app, and it's working perfectly, and you think it's perfect, and then the product manager is like, you know what I need you to add now? Conversion tracking and this and that, and Google Analytics, and oh, we just got this crazy new mobile download black magic, and we need you to put that in there somehow. And like pretty soon, your beautiful code is just like, it's like right in the middle, and then there's all this other stuff around it, talking to all these external vendors. One way to use a bus system like this is to not put that code there and just publish that say, somebody signed up or somebody looked at this thing. And then way over here, not messing with your core code that's driving your business, but it's just for metrics, you can subscribe to those events and talk to the Google Analytics, or a lot of people are using these email sort of event-driven drip campaign kind of things like that for email marketing. We've gotten a lot of value out of that because it's about each piece of code being super focused and doing what it does best. Logging is a super cool case too. Lots of things happen in your product, and you might want to know later that those things happen. And so you can definitely write those to the local logs and then use something like Splunk or Sumo Logic or a variety of Unixy things to collect all those up. Another thing is to publish them to this bus, because you're doing that anyway for a lot of these cases. You can imagine subscribing to all events and writing those into a system such as Elasticsearch. And basically, that Elasticsearch becomes a log of every interesting thing that ever happened in your system. And you can go back and use that for debugging and or really cool hack day projects up on the wall or whatever, what's happening in real time right now and things like that. We got a lot of value out of that as well. All right, good. I sold you, right? Who's sold? Who wants on the bus? You want on the bus? All right, it's good. Yeah, people. Tickets right here for free. All right, cool. So you want to get on the bus. There's lots of ways to do this. Certainly talking about the Redis ways to do it, but there's other systems as well. It's sort of I'm a chief architect, which means I don't have to code up here on stage. I can just do these presentations. It's nice. All right, cool. So here's the message block architecture. You Google it. This is what you get. And if I had a mic that I could drop, I'd drop it at this point, because obviously this is how you do it. And we're done. They're all from Microsoft, by the way. I just noticed it. It's legit. All right, cool. All right, so let's say you want to get started. The one I've been talking about here is called QBus. That's the sort of Redis case that I walked through that's built on Rescue. Somebody else saw it was called Rescue Bus, and then we expanded when someone wanted to use Sidekick, which is another thing that's like Rescue. You could theoretically put other systems in there as well, or considering adding others, but it's what I've talked about before. It puts it in an incoming queue, then examines who's interested and adds it to more queues. Super simple, and it uses the infrastructure that you already have. Well, you may already have it. We at least already had it. Lots of people already have it. All right, so let's say you graduate from that and you're super hipster. You might want to try this Kafka thing out. LinkedIn made this. It's kind of the same idea. It's also sort of a storage mechanism, too. The Redis version I just talked about is very fleeting. Things come in, things go out. It's kind of a combination. And then we make it more permanent by subscribing and writing it to Elasticsearch and logging, like I talked about. Kafka has the storage side effect, and it does a lot of the subscription things. Certainly would check that out if I was looking into adding bus systems. You can also go to the next talk downstairs with my colleague, Evan, who knows even much more than I do. He, in fact, told me the thing I just said about Kafka 10 minutes ago before this talk. He's giving a talk downstairs at 2 that you should check out. If you're enterprise, people seem to like this RabbitMQ and lots of plugins on top of that. And then there's other MQs, a lot of things with MQ on it. I'd Google *MQ and see what comes up. It's the same notion of bus systems. Definitely worth checking out. Or, you build your own with Redis. It's not that crazy. You need to be able to push things onto a queue. We use rpush. You can pop them off of the queue using lpop. Theoretically, you could lpush and rpop too. It can go either way. It's flexible like that. You need to be able to sort of add to what apps do I have subscribed, and then have a set of what those subscriptions are. I'm interested in ratings, and I'm interested in new signups, that kind of thing. Just to fully play it out, these were some of the main interesting steps in the thing I talked before. And here we do an rpush, then we do an lpop, see who subscribes with an hgetAll, and then push back onto Redis, and then do an lpop again from the profile app. Certainly no black magic here, which is one of the values that we got from it. All right, so you're sold, you're going to do it. Best practices, my recommendations to you is always be publishing. Especially, basically, we publish every time a row in our primary data store, MySQL, changes. If that's crazy for you, maybe you have more rows than I do. TaskRabbit is kind of cool because per row, per request, we make a lot of money, which is pretty good. I don't know what it is, but like it's certainly more than like per Twitter request or per CNN request or something like that, which is cool. So we don't have that many, so maybe at a certain scale, that's too much for you. Or you have to Redis cluster and all those other things, which we're doing, and I'm sure there's lots of talks on. But at the very least, we find the interesting things happen when the state changes. So if you've got a state machine, which I also highly recommend, but that's another talk, some invoice goes from like sent to paid, that's a great time to publish, because that's usually when an email is sent, or it's a conversion event, or you want to record that in the logs, or something like that. And you're going to be publishing a lot, so set up patterns, code that is shared between all of your things, so that all events are more or less the same, with minor naming differences. So I'm certainly never, when I subscribe to it, I'm not surprised of the keys that are there. They're always called, I don't know, user created is a pattern that we have. And if you were subscribing to ratings, it would be rating created, right? Like there's just patterns, just general good, software things, no surprises kind of rules. And start super small. Maybe you just want to start publishing and doing the logging. And then the next time you have a project that wants to do something and you basically don't want to muddy up your main code, you've got this external vendor, subscribe to that and do the code to do that extra thing over here. And then feel great that you didn't change your quote-unquote real system. And that's it. We got a blog that talks about a lot of these things. We are hiring. I'm on the Twitters. And here's $20 off your first task. That's it. Thank you.
I have a question. No, sorry. I have a question about consistency. So let's pretend the guy on the right pulls something off the queue and he dies. What happens exactly?
Yeah, certainly. That's everyone's like, I got this cool new data store, and then someone's like, but do you lose data? And you're usually like, sometimes it happens. So let's say that it's in rescue 2, like it's you build that up on that same pyramid, right? And so you go all the way down to the bottom, and you look at the model there. And so if you pop something off of Redis for a time, that only exists in the memory of the process that just popped it, right? And so it's certainly acknowledged that if that server was just the power went out, right? Like that event is straight up gone. That's the situation. There's mitigation factors of that. You'll notice that my rating code didn't say, oh, someone just got a 5, so I'm going to add that to some total and then divide by the new total or something like that. It looked at all the ratings they've ever gotten and recalculated the new average, which is to say, if you want to get fancy, that code is idempotent. And so generally speaking, which means that if you could run it 10 times, it always has the same result. And in this case, it's basically like, let's say you missed an event. The next time you got a rating, it would basically self-correct. And so that's one of the strategies to have in any of these systems where you might lose an event. And you could be like, oh my gosh, I just lost a bunch of events. You could imagine replaying that rating change to them, and it would still come up with the right number. Now, that code does have, there's one other case maybe. Maybe you have that external vendor case, and they're down. It's 503 or something when you talk to them. We do have retry built into the thing, so we have exponential back off. So if the whole system didn't go down, but something it's doing broke for some reason, it'll try again 10 seconds later, and then 20, and then a minute, and then an hour or something like that.
Well, you have to do a little better job, at least on the accounting side, because you go on and say, hey, pay me, and the guy says, sure, and he never comes back. You must have some kind of accounting mechanism that you run through.
Yeah.
And also you might even have a notification coming back again, payment received, and you match up the requests and the receives, and if they don't have parity, there's at least something wrong, right? So.
Yeah, there's certainly, with any case, so you realize this hole exists, right? And every system has trade-offs. And so you understand the trade-offs of the system that you have, and then put things in place. And you can certainly imagine there being states on the payment situation. It went from created and paid, and then some dates involved. And why is this payment was requested 4 days ago and still hasn't been paid, and now we need to, maybe we lost an event. I don't know. Shit happens, right? And so, and sort of backing up that. And I don't think there's one perfect solution to everything, and so I think that's a general case, which is you have to understand the trade-offs and limitations of the systems you're using, and then put fail-safes in place, definitely.
So I'm wondering, what's the throughput of your Redis message bus? Because it seems like you save everything, every event into this bus. And also, is there any chance it become the bottleneck of your system?
Yeah, it's great. So what's the throughput? Well, one great thing is that they're all queues, and then at least once they get fanned out, there's multiple copies of it. And so if the code is slow on fraud analyzation, that's not backing up this review thing, this rating thing, for example. But that incoming queue is certainly a candidate for a bottleneck, right? And so basically the question becomes, how quickly can Redis pop things? And then secondly, how fast or slow is the code that analyzes who it needs to fan out to? And so we certainly have, I don't know. The next tech guy probably knows more than I do. He's DevOps, right? I don't know. We certainly have tens of thousands of per second things going through that. And that's the scale we're currently at. And you can, assuming the bottleneck isn't Redis popping things, which it's not, you can always put more workers on that too. And so you can imagine a set of workers that, say the profile workers that are popping things, say rating calculations or whatever, and it works his own queues. And then if he gets to the bottom, sort of a search path, right, like priority order, he works his own. And if he gets to the bottom, he also knows how to be a driver, sort of like a substitute driver, if you're using the metaphor. And so if he's got nothing to do, then he can pitch in with the driving too. In exactly the same way we just talked about, you should have a health check that monitors the queues of these things and understands if you are backing up, and maybe auto scale up, new workers and things like that. One thing that I'm probably about to do, you could also imagine having SLAs, service level agreements, or put specifically, multiple incoming queues where you explicitly, when you publish, say, you know what, this is just not the most important thing in the world. We made this bus system, and at some point our data science team realized that if they published something to this bus, that they could look at it in Elasticsearch later, and they put a lot of things through the bus. But those are certainly less important than that this person needs a push notification that he just got hired. And so you can imagine putting that on a second tier of things to process and do them second. Hopefully that was helpful. else? Probably wait for the microphone if you don't mind.
Hi, yeah, so my question is around this multi-tier that you're talking, right? Like the queues, you can decide there are different tiers.
Yeah.
But is it like something possible that you can drop off the lower tier? If you we're talking about
Right.
performance being an importance, and if I'm a worker thread, there are not that many, and I want to keep that limited.
Yeah.
I want high performance on my high priority tasks, and
Right.
probably just drop the low priority task. Is that?
Right. So in Rescue and probably most background job processing systems, there's inherent priority of things that get worked, right? And so we've certainly had times when things are not going that well on our back end, and I just got a PagerDuty alert or something like that, and there's some queue way at the bottom of that priority list, and I don't have the example here. I can click into that queue, and then I can basically be like, you know what? Redis, like del delete the key. Like, sorry, data science, like us crashing for everybody is not worth like your user sentiment analysis for the last 20 minutes. Like, it's gone. And oh good, there's 100 more megabytes in Redis that can get us through this outage-ish problem that we're having right now. And so that's certainly something that we've done in times of need. There's other approaches to that. You could imagine like using a load balancer or 2M proxy or just a variety of other DevOps things to sort of take that whole Redis instance and sort of stop putting new things in it and then swap in a whole new one, and now you're writing to that one. And this one could get drained completely separately, and nobody is now writing to it. It's similar to how Google Analytics works, to my understanding. They sort of fill a bucket up and then process it. Those are another effect that you could do if you saw an influx of events and/or all your workers died and coupled with an influx of events. One thing that I've learned is that people watch TV with their laptops, and then when the commercial comes, they Google whatever the lady just said on Good Morning America or whatever. And so like all at the same second, they'll all come to TaskRabbit and sign up at exactly the same time. And you could certainly imagine your user-created events, scaling out at that time. And coupled with some other issue, like you might be in that situation to drop a queue or swap in a new empty Redis bucket. Yeah.
You had mentioned that you do, in some cases, you're scaling up and down the worker fleets that may be working on these queues.
Yeah.
Thinking about what you said previously about resilience and when you've picked up a message, haven't acted, it sounds like Rescue doesn't have a built-in concept of redeliver, if not act. Is that really not that scary? If you insist coming and going due to auto-scaling and you don't have explicit act?
Right. It sounds like I should say, yes, I'm super scared. That sounds like but, I mean, there's certainly different, like every given event or thing that's happening in your system has different importance levels and SLAs and things like that. And so if I lose one of those metrics events, like I'm sure Mixpanel and Google Analytics are every now and then drop a random event, and it's not the biggest deal in the world. And we certainly have things in that tier, and then we have things in the other tier. And we have like how important it is to make sure it eventually happens and how important that it needs to happen in real time certainly factor into the backup mechanisms in place. And so thus far, we didn't find that it was necessary to build in a generic ACT system. We take the cases that have basically the highest level. It absolutely needs to happen, and it needs to happen as soon as possible, all the time, and we build in a backup plan. And then the second tier would be, it absolutely needs to happen, but like whenever, eventually, soon. and we build in a backup plan in that. And then there's certainly other ones like, oh, missed a click. All right. Thank you, guys. Appreciate it.